So I have the variables written out to the left for both problems. You'll notice that for the pressure problem, on the top problem, the pressure section, I ended up making sure that I had the conversion from torr to ATM. That's just 760. The volume, this was milliliters, so I wrote it as liters. The molar mass is just molar mass, so it's R. And then right here, I included the whole conversion to Kelvin. So I'm going to fill out the equation. So I have 0.460 grams times 0.0821, and that's liters ATM per mole Kelvin times 127 plus 273.15 over 385 torr times 1 ATM 760 torr. I don't have to have parentheses. Well, I do, since I'm multiplying like that, I do need to have a parentheses like that. What I was going to say is I can put this whole entire denominator in a parentheses, and that's fine. But this section has to be inside of its own parentheses. And that's Kelvin, and that's Kelvin. So hopefully you can see how the units are all going to cancel out. So we have a liters. Let me find my liters. Oops, I just realized that I wrote the wrong thing down, didn't I? This bottom thing isn't supposed to be Kelvin. That's a duplicate. This bottom thing is supposed to be 0.429 liters. 59 liters. Sorry about that. Now I have something for my liters to cancel with. And then I have something for my ATMs to cancel with. I have something for my torr to cancel with. I have something for my Kelvin to cancel with. And my unit that I'm left with is a gram per mole, which makes perfect sense because we're talking about molar mass. We put that all in the calculator and we will get 0.460 times 0.0821 times parentheses 127 plus 273.15 divided by 385 divided by 760. And then, I'm not sure how I ended up with the one. Divided by 0.4259. And I'm going to scroll left because it looks like somehow don't think it's going to, oh, it was included in there. Okay. So when I put all of those numbers in, I get 70.043. And if you're wondering about sig figs, I have 1, 2, 3 here, 1, 2, 3 here, 1, 2, 3, 4. When I add those together, I'm going to have at least 3. So I'm going to say that my sig figs on that number are just 70. Now, if you go ahead and you divide that by 2, you're going to get 35. Now, I know that there's not a periodic chart value that's exactly 35, but there's one that's very, very close that is diatomic, and it's chlorine. Chlorine has a value of 35.45. You multiply it times 2, and you get the 70.8 value I was talking about earlier. But anyways, or 70.9, you can see what that element is. So that's kind of cool. Then we go on to this one. We have, I'm going to use the version that's over on this side. So this, and this equation's nice because it has a little bit less in it. 0.0847 grams per liter times 0.0821 liters ATM mole Kelvin times 17 plus 273.15 Kelvin over pressure, which is 760 torr, times 760 torr, or 1 atm. And if you wanted to completely cancel those out, you can at this point. Notice that our atms will cancel. Our kelvins cancel. Our liters cancel. So we're left with grams per mole, which is perfect because that's what we want. So 0.0847 times 0.0821 times parentheses 17 plus 273.15, and then it'll just be divided by 1. And that gives me, if I look at my sig figs, 1, 2, 3 sig figs, most of the things in there have 3 sig figs, so that's going to give me a molar mass of 2.02 grams per mole. It wants to know, what is the gas? Well, it doesn't tell you it's diatomic, but it's really the only thing that it could be is hydrogen. It's the only thing that's that small with that mass. H2, because each H is 1.01.